So recursive sequences, it's when a term is defined by the preceding term. That would be the definition for a recursive sequence. So it's kind of like the domino effect. You have to know what the term previous is to get the next one. And if you miss anything in between, then the dominoes stop falling. So we have to build up from it. So I will show you how the little subscripts work, but first I want to just go. There's not a lot of work to show here if you understand what the formula means. So first we're going to do the easy direction. So we're given the recursive rule. We can tell it's recursive because we're told the first term. And then we're just going to write out the first four terms. So the first term is very easy. It's a sub 1 equals 3. And so we know for our answer that 3 is the first term, so comma. And then to understand these formulas, what you need to know is a sub n minus 1. You can see it in both. A sub n minus 1. You're always going to see that. And that stands for, what is that? If a sub n is the nth term, then a sub n minus 1 is the term before it, or previous term. Yeah. Previous term. And as long as you know that, then you can translate this. This means that to find any term, that's what a sub n, right? A sub n is any, that's the nth term in general. To find the nth term, you take the previous term, which should be a sub n minus 1, and then subtract 7. So what would the next term be after 3? If we're just subtracting 7 each time? Negative 4, right? So it goes 3, negative 4. We're going to write out the first 4 terms, and then it becomes 3, negative 4, and then negative 11, and then negative 18. Yeah. So those are our first 4 terms. And I want to show you that if you plug in n is 1, n is 2, n is 3, that these formulas work. So a sub 1 equals 3. This is kind of what the computer program would do. A sub 2, I'm just, wherever I see n, I'm plugging in 2. A sub 2 minus 1 minus 7. So a sub 2 equals a sub 1 minus 7. And we know a sub 1 is 3. So this equals negative 4. If you were to just plug in n. So then we'd go the third term. A sub 3 equals a sub 3 minus 1 minus 7. So a sub 3 equals a sub 2 minus 7. So it's always the previous term minus 7. You don't need to do that if you know what the formula means. So let's try this one. Now, today, actually, when you do your assignment, you're going to see that it's okay to start with the 0th term. It's perfectly fine. And sometimes it makes writing the formula easier. So, oh, by the way, what type of sequence is this? Yeah. So arithmetic. That one's arithmetic. And what do you suspect this is? 0.5 times, yeah. So you should suspect geometric. So now we're going to be able to write recursively, arithmetic, and geometric. So the first term, or the 0th term, is 162. And then how do we get the next one? We multiply by 0.5, which gives us just a half of 162. 81. We can do it in our head because half of 16 is 8 and half of 2 is 1. And then what's half of 81? 40.5. 40.5, and half of 40.5 is 20.25. 20. Good. So those are our first 4 terms. So that's the easy direction, writing them out. Now we have to come up with this formula. And the most important part is don't forget to define the first term as a part of your formula. Otherwise, it breaks. It doesn't work. So the first thing we have to do for our answer is do a sub 1 equals, and we could use a sub 0, but we'll just use a sub 1 equals, what is the first term? 19. Nice. And then we would say a sub n, that the nth term, equals the previous term, which is a sub n minus 1, And then what do we do to the previous term? Minus 6. So you can, it's not, recursive definitions are much easier than explicit. But they do have a disadvantage, which I want you to think about and tell me what it is. So I want this in your notes. Always include the first term, because otherwise the whole thing is wrong. Don't forget to do that, because otherwise you can't even use this formula. You wouldn't know where to start. So you always have to include the first term. And is that arithmetic or geometric? Arithmetic, because you're always adding negative 6. That's the common difference. Okay, this one, a sub 1 equals what's the first term? It's 2. That's easy, right? It's right there. And then you would write the nth term. The formula for coming up with any term is to take the previous term, leave a little space. And what are you doing each time? You're multiplying by 7. So it's 7 times a sub n minus 1. And you can tell it's geometric because you're multiplying by a constant. So that's it. And so what's the disadvantage of, since this is easier to write, what's the disadvantage of recursion over, Michelle?
If you're trying to find a number, like where the term is really high, it takes a long time to
it takes a long time to get to it. So if I want, like, today in super stairs, we're going to find like the 100th term, or if there's 100 stairs, we're not going to do 100 stairs, or if there's 1,000 stairs, I should be able to just get the answer without going through the 99th term, the 98th term, the 97th. And if I had a recursive definition, it takes a long time. It's easier to think about, but it takes too long.